Hello, hello, and welcome to my science tutorial. And yes, finally it is here. So welcome everyone once again, and welcome to our very first episode of Shocking Hour. Now, this is the space where learning gets exciting, smart becomes fun, and you become unstoppable. All right, so I'm your host and learning buddy, Samuel Kotoka. I will be your live streaming partner. I will be your host for teaching on this platform. We are two. I have myself and my colleague Lawrence Tenu, who will also be taking us sometimes during our live stream session. And together, we are going to dive deep into the ocean of knowledge. We'll be looking at topics like subjects like physics, chemistry, biology, mathematics, you name it, we nail it or we crush it. Right. So whether you are preparing for WASE or your school exam, whether Cambridge or JAM, or you are preparing for your university entrance exam, or you are just here to sharpen your brain, this hour is for you. Okay. So there are no boring lessons here. These are just real talks, real questions, and real wins. And did I mention that we'll be having games, shout outs, and giveaways and live challenges on this our live stream? Yes, we will be having those fun activities as well. So every weekday, from Monday to Friday, we will tackle a major subject. And today, we are kicking things off with physics, which is the science of matter, motion, and energy. Okay, so if you've ever wondered why things fall or how electricity powers our phone, we are going to be breaking all those down for us. So grab your notebook, invite a friend, like the live stream, share with your friends and colleagues, and drop some fire in the comment section and let me know that you guys are watching me live. And then if you're ready to level up, I'm ready to help you. And then let's flood the chat with shark mode on and invite our friends to join us. So this is Sharking Hour and class is in session. All right. So, like we are saying, we are dedicating this time every evening from Monday to Friday for live streaming, where we get to interact with students live on YouTube, and I get to teach, and we get to go through a lot of questions and to help us prepare for what we have for the day. Now, so if you're wondering what is Sharking Hour, okay, so Sharking Hour is a it's a time, like I said, designed by my science tutorial to help us learn life on YouTube. Okay, so we are starting today, 1st July 2025, and then the platform where you have this Sharking Hour lesson is my science tutorial platform. So basically, Sharking Hour is just a live online study session designed for high school students, senior high school students across the West African country. But if you're not in West Africa, if you're in India, US, UK, Canada, once you're in high school, this live stream session is for you. Okay, so this is your go-to platform to revise any key topic you want at all. You ask questions and then you prepare smarter over here. So this is all going to be in a fun and interesting way. So if you are a student from any part of the world, you can join this Sharking Hour every day from 8 p.m. to 9 p.m. Now we'll be voting on the time later on, but for now we are starting at 8 to 9. All right, so what time works best for us? So for now, we are going with the first option, which is 8 p.m. to 9 p.m. But if you want us to change the time, you can suggest your time in the live chat, and whether you want 8 p.m. to 9 p.m., 9 p.m. to 10 p.m., 10 to 11, or 11 to 12. You can suggest it, and then I will stick with that time. Okay, so I'm here for you guys every evening. We are going to learn. So why you should join Sharking Hour? Okay, so this is going to be a live session on key high school topics to help students learn life. If you don't understand something, you just drop it in the comments or in the chat. I will follow, and then I will let you. I will go back and then revisit the topic or re-explain again so that you understand. We will be solving past questions, both objective and subjective, on this platform, and then you get to ask real questions, and then you get real answers. We'll also be doing live Q&A sessions, so there is a lot to be expected from this live stream. So, like I'm saying, the name of this live stream is going to be Shocking Hour. So, we'll be live streaming biology lessons, we'll be live streaming chemistry lessons, core mathematics, and then we'll be looking at elective mathematics as well, physics, all these topics. We'll be looking at them all on this platform called My Science Tutorial, and the live stream is Shocking Hour. So please, let's drop some fire in the comment section. All right, so like I said, today we'll be looking a little bit about physics. So we'll start by knowing what physics is, and then some little bit of mathematics that we need to know before we start with our lesson. Now, this is going to be how the lesson is going to be. So we have our white, background over here. So today we are talking about physics. So I will be writing. You guys will be seeing. If you don't understand anything, just let me know in the chat, and then I will revisit that particular topic for us to understand. Okay, so we'll be looking at physics today. So let's start by looking at what the definition of physics is. So the word physics is derived from Greek word, and then physics is the science of matter and its motion, as well as the space and time. Okay, so physics is basically the science of matter and its motion. So when we are talking about physics, we are looking at the study of matter and its motions and its motions. Now we can all agree that everything around us, including we human beings, are all matter. Okay, so any study that has to do with matter and its motions, right? That is what we are referring to as physics. Basic definition of physics. Now there are a lot of branches of physics. Going too much into this, but we have a lot of branches of physics. So just for time's sake, I'll be mentioning them quickly. So we have astrophysics, atomic physics. We have biophysics. We have chemical physics. We have what we call molecular physics. We have acoustics, we have electromagnetism, we have fluid mechanics, we have geophysics, we have nuclear physics, we have particle physics, we have quantum physics, thermodynamics, theoretical physics, solid state physics, space physics, classical physics, statistical mechanics, and then surface physics. We have a lot of branches of physics, but that is not what today's live stream is about. So today's live stream is basically about some basic mathematical concepts that we need to know before we start looking at physics in general. Okay, so if you are a student and you are taking physics courses, your maths background needs to be strong. So we'll be looking at some basic mathematical concepts. Mathematical concepts that we need to know in physics. Are we okay? Now, these concepts, we have a lot of them. So the first one is how to form algebraic expressions. We'll be looking at them one after the other. How to form algebraic expressions, how to approximate and round off numbers. You need to know that as well. How to write scientific notation or standard notation. You need to know how to do that as well. You also need to know how to change a number in standard form. You also need to know unit conversion, how to convert from centimeter to decimeter to millimeter, whether it's volume, whether it's mass, whether it's time. You need to know how to convert units in physics. Then we'll look at some basic laws of indices. And then we also look at some power properties, the quotient rule and all those stuff. We'll be looking at all of that. And you also need to know how to do change of subject. You also need to know that as well as variation and how to solve some basic mathematical expressions. So these are the basic things that you need to know in mathematics before you go ahead and try to touch physics. So like I said, I mentioned a lot of things. I mentioned indices, that these are one of the things that you need to learn. I also mentioned unit conversion, so we'll be looking at all this today during this live stream. Unit conversion. Okay, so we have here I have someone from Jibri Musashi. Are you a physics teacher? Oh yes, I'm a physics teacher. I teach a lot of things. Okay, someone is saying I don't understand why he said physics is the study of matter and its motions. Oh, okay, okay. All right. So basically, when we talk about physics, we are saying that physics is the science of matter, motion, and energy. Okay. So the study of matter and motion, right, and its motions. Okay. So we are saying matter is anything that has weight, mass, and occupies space. That is matter, and the motions it undergoes are all part of what we are saying is physics. So the study of matter, motion, and let me add another one, the study of matter and its motion and energy. Okay, this is what we are saying is physics. Okay, this is just a basic definition. It might differ from textbook to textbook, but the principal idea is that you are studying matter, its motions, and then energy. Are we okay? That is what we are saying is physics. Okay, so thank you so much for asking that question. I'm sure this our friend is from India, so thank you so much for asking that question. All right, so let's continue. Like I said, we will be looking at indices. We'll also be looking at unit conversion. Uh, After that, we will be looking at change of subject for today's particular live stream. These are the three basic topics that we'll be looking at. Now, if you don't know, on our main page, my science tutorial, we have lessons on indices, unit conversion, and change of subject. We have lessons on this already on the main page, so you can just go to go to YouTube, just type my science tutorial and go to our playlist, and then you will find lessons on this already made for you. All right, so let's go with the first option over here, indices. Let's look at some basic things that we need to know about indices, and then we proceed with the rest. So the first topic we'll be looking at today is indices. Like I said, these are some basic math concepts that you need to know before you start learning physics. Okay, so the first one we want to look at is indices. So indices is the index form or index notation of writings. Okay, so when we have some numbers or when we have some alphabets or mathematical expressions, some are expressed in index form or index notations. Okay, so the key word here is index form or index notation. Are we okay? So we need to know how to maneuver our way around this. Right, so let's look at the first law of indices. Okay, so let's look at the first law of indices. First law of indices. Okay, so for example, let's say we have a raised to the power 3 multiplied by a raised to the power 2. Are we okay? What will be our answer? Okay, now in indices, the first law of indices says that when you have a number with an exponent multiplying the same number with another exponent, you add the exponent or the powers. Okay, so what it means here is that for this particular case, where I have a raised to the power 3 and then a raised to the power 2, all I need to do over here is to add the power. So I add 3 and 2 to get my answer. So over here, I'm going to have a raised to the power 3 plus 2, and this is going to be a raised to the power 5 as my answer. So this is the first law of indices. So you have the same base, okay, with different exponents, or the same exponent, okay, but once they have the same base and you are multiplying, you add their powers. The emphasis here is on the same base. It should be the same base. For instance, if I have 2 raised to the power 5 multiplied by 2 raised to the power, let's say 7, my answer over here will be equal to 2 raised to the power, then I add the 5 and the second power 7 over here, and then this will give me 2 raised to the power 12 as my answer. Or for it to be much simpler, let me expand what I have over here. So I have here a raised to the power 3. That means I have a multiplied by a multiplied by a. And then I have my multiplication sign over here. And then this guy is what I have here, a multiplied by a. Are we okay? Now, if you look at it, a multiplied by 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 itself 5 times will just give you a raised to the power 5, which is the same as what we have over here. So that is the first law of indices. So you have the same base, you add the exponents. That is the first law of indices. All right, so let's just look at some very quick example, and then we look at the second law. Now, this law is what we call the product law. Okay, another name for the first law is what we call the product law. Are we okay? All right, so just a quick example, and then we move forward. So for instance, let's say I have example number 1 here. I have x squared multiplied by x cubed. Are we okay? What is going to be my answer? The second example over here is 2x raised to the power 4, y raised to the power minus 3, multiplied by, so this is another bracket, 4x raised to the power minus 2, y power 6. Okay, so these are the two examples that we have to solve under the first law of indices, which we are also calling the product law. All right, so let me use a different color so that we see the answers to this particular problem. So for the first one, I have x raised to the power 2 multiplied by x raised to the power 3. So this will be equal to x raised to the power 2 plus 3. So I add just the powers because the bases are the same. So my final answer will be x raised to the power 5. Are we okay? Now, when we look at the second example, I have 2x to the power 4. Sorry. So 2x to the power 4, y to the power minus 3, then multiplied by 4x to the power minus 2, y to the power 6. Are we okay? Now, when we have an example like this, let me use black. What we do over here is that we just go ahead and multiply. So first of all, we multiply the number by the number over here. So 2 multiplied by 4. So we have 2 multiplied by 4. Then we have the x also multiplying the x. So we have x power 4 multiplied by x power 2. Then we have the y also multiplying the y. So we have y power 3 multiplied by y power 6. Are we okay? Now, 2 multiplied by 4 will give us 8. Over here, we have x power 4 multiplied by x power negative 2. So we have here x power 4 minus 2. Okay, or plus minus 2, which is the same as 4 minus 2. Then for the y, we will have y power minus 3 plus 6. And then this will be equal to 8 x raised to the power 4 minus 2 will give me 2. Then I will have y minus 3 plus 6 will give me 3. Okay, so therefore this is my answer. Are you okay? So this is my answer. Very good. So this is the first law of indices that we are calling as the product law. Now let's look at the second law of indices, which we call the quotient law. So second law of indices, which we also call the quotient. 5 minus 3 will give us 2. Or another way we can do this is we have a raised to the power 5 to the power 3. We can rewrite this as a raised to the power 5 divided by a raised to the power 3. So we are just rewriting what we have here as this. And then from here, we can now write a raised to the power 5 minus 3, and then that will give us a raised to the power 2. So this is the quotient law. So for example, if I have so let's look at an example. Let's say I have 3 raised to the power 6 divided by 3 raised to the power 3. It means my answer over here will be 3 raised to the power 6. Because they are dividing, I'll subtract the 3 over here from it. Then that will give me 3 raised to the power 3. Are you okay? And 3 raised to the power 3 in this case is 27. So we write 27 as our answer. Or if you are given the question in this form, x raised to the power 6 over x raised to the power 2. So this will be x raised to the power 6 minus 2, and this will become x raised to the power 4 as our answer. Are we okay? So this is the quotient law. Now let's look at the third one, which we call the power law, or the third law of indices, which we also call the power law. Let's quickly look at that. So the third law of indices, which we are also calling the power law. Okay. Now for this particular law, we have, for example, let's say I have a raised to the power m and then raised to another power n. So over here, my answer becomes a raised to the power, because these two are powers, I just multiply them. They're already at the top, so you multiply them. So it becomes mn. So we multiply them. Say, for example, so let me give an example so that we can understand. Please, if you don't understand anything, just write it in the comment section. I am watching, and then I can answer for you. Very good. So in this case, let's say I have an example, 2 raised to the power 4, bracket close, raised to the power 5. So this will become, per the power law, we are saying this will become 2 raised to the power 4 multiplied by the 5 at the top. Okay, so either you use dot or you just use the multiplication sign to be on the safer side. And then 4 multiplied by 5 will give us 20. So our final answer over here is 2 raised to the power 20. So another example, say I have 3 raised to the power 2 cube. Are we okay? If I have something like this, my answer over here will be 3 raised to the power 2 multiplied by 3, and this will give me 3 raised to the power 6. So this is my answer. So these are some laws of indices that we are talking about. Now there are some properties of and numbers or indices that we can look at, but we'll leave those ones for now. Now let's look at quickly look at the second part that I said we'll be looking at. So that is a unit conversion. So now let's look at the second part, which is unit conversion. So I'll be sharing the timetable for the Shacking Hour lesson very soon on the page, so we know the topic we are treating for each day. So let's look at unit conversion. All right, so basically we have a lot of units. We have a lot of SI units. We have basic quantities and derived quantities. So one, we have what we call the basic quantities or basic units, which are derived from basic quantities. And then we have derived quantities. Okay, so basic quantities, they are just quantities that cannot be obtained by combining 2 or more quantities. For instance, we have 1, we have length. Okay, we have length. 2, we have mass. and then 3 we have time. Okay, these are basic quantities. Now when we combine two or more of them, then we get derived quantities. So derived quantities, we can have quantities like pressure, force, area, all these things, they are derived quantities. Are we okay? So for instance, pressure is force over area, and then force is mass times acceleration over the area is length times breadth, or length times width. Okay, and then acceleration over here, if you want to break it further, this will be mass times acceleration is velocity over time. Are we okay? Over length times breadth, which we'll be looking at later on in indices, right? So that is why it is a derived unit. So you realize that we have mass. Velocity can also be broken down to displacement over time. We have another time over here. We have length over here. Breadth is also length, a type of length. So if you look at it, we have multiple basic units in there. That is how come we are saying it is a derived unit. Okay, for force, it is the one at the top over here already. And then for area, is length times breadth, which is like length squared. Are we okay? So it is also a combination of two lengths. That is how come it is also called a derived quantity. So for basic quantities, for instance, for length, we can measure it in meters, kilometers, centimeters, decimeters, and so on and so forth. For mass, we can measure them in milligrams, centigrams. We have decigram, and then we also have kilogram, and then beyond kilogram we have ton. And then for time, you know how we measure it. We have seconds. So for time, we can measure it in seconds. We can measure it in minutes. We can measure it in hours. And then from hours to days, to weeks, to months, and then year. Months and then years. Are you okay? These are the units. So we need to know how to convert. For instance, if I want to convert length from meters to kilometers, how will I do that? If I want to convert from kilometer to centimeter, how can I do that? Now, knowing this thing is very, very important, because when we are dealing with physics, we'll be dealing a lot with SI units. Now, for the units, most of them has to be in the standard state. For instance, length is mostly measured in meters. Are we okay? Now, if the question or kilometers, for instance, if the question demands that I leave my answer in centimeters, meanwhile the question is given to me in kilometers, I should be able to convert to centimeters, and that is the essence of learning how to do unit conversion. Now, this is very simple, so we'll be looking at it one after the other. So let me just get some space, and then we continue. Right, so guys, if you're enjoying so far, drop some fire emoji in the comment section, and then we continue. All right, so let's continue with our unit conversion. So for instance, we have 10 millimeters will give us 1 centimeter. Or let's go this way. We have the unit conversion. We move from millimeters to centimeters, and then from centimeters we go to decimeters, then from decimeters we go to meters, then from meters we go to kilometers. Now, what is important is to know how to convert between each of these. Now, I'll put something like this here. Let me use red. Okay, just so we are on the safer side. There's a reason why. All right, so The basic form here is that know that it is millimeter to centimeter to decimeter to meter for now, and this will help you. So from year to year is just multiplied by 10. So each of them, so from millimeter to centimeter, just multiply by 10. If you are moving from centimeter to, let me use a different color. If you are moving from centimeter, to decimeter, it is also times 10. If you are moving from decimeter to meters, it is also times 10. Are we okay? What it means is that if I want to move from millimeter to decimeter, it will be 10 times 10, which is 100. If I want to move from centimeter to meter, it is also 10 multiplied by 10, which is 100. But if I want to move from millimeter all the way to meters, it is 10 multiplied by 10, which is 100 multiplied by 10, which is 1000. Okay, so what does this mean? What is all this about? So what it basically means is that, let's say I have 20 millimeters. Are we okay? And then I want to convert it into centimeters. Are we okay? What it means here is that, remember, the more you go up this scale, the higher the unit becomes. Are we okay? So from year to year, I say it's times 10 times 10 times 10, because the reverse way is also like that. So for instance, if I have, this is how it goes. Let me use centimeters rather. So if I have 20 centimeters and I want to convert it into millimeters, are we okay? It means that I have from centimeters over here, I want to convert over here back to millimeter. I need to multiply it by 10. Are we okay? Because centimeter is a higher unit, so it will be higher when I convert it to millimeters. So it will become 20 multiplied by 10, and that will give me 200 millimeters. Now, say I have 20 millimeters and I want to convert it to centimeters. So from millimeter to centimeter, then I divide by 10. Are we okay? So what it means here is that I will have 20 divided by 10, and that will give me 2 centimeters. Are we okay? So basically, this is what we mean. So from millimeter to centimeter is 10. From centimeter to decimeter is 10. From decimeter to meter is also 10. Now, depending on the direction you are going, you either multiply or you divide by 10. Are we okay? So when you are converting from a smaller unit to a bigger unit, which is from millimeter to centimeter, you divide by 10. In this case, millimeter to decimeter, then you divide by 100. If you are moving from millimeter to decimeter, that's you are converting the unit from millimeter to meters, then you divide by 1000. But if you are going the other way around, from a bigger unit, which is centimeters to millimeters, it will be more. Are we okay? It's just like converting $10 notes, okay, to smaller currency. Okay, you're going to have more coins. Or let's say we are converting 10 Ghana cedis in this particular case into 1 cedi notes. 1 cedi note, you are going to have 10 of 1 cedi note, which ideally just gives you 10 Ghana cedi note. Okay, so let's look at some examples on this particular case. All right, let's look at some examples. Okay, say I am to convert 100 centimeters to meters. How will I do this? Are we okay? Now, this is an example. So this is how I will approach this particular problem. So to me, in my mind, I know that I have from millimeters to centimeters to decimeters to meters. Are we okay? Now I am converting, in the question I'm converting from centimeter to meters. So I'm expecting it to be smaller. Okay, because I'm converting from a lower unit to a higher unit, so it's supposed to be smaller. Now, do I divide by 10, or do I divide by 100, or do I divide by 1000? That is why this scale is important. So in this case, you are moving from centimeter to decimeter to meter, so you are moving twice, and each move is 10 10. Okay, so it means that the movement from centimeter to meter, it is what? 100. Are we okay? So in this case, this is what you have to do. Are we okay? So you said over here, 100 centimeters, 100 centimeter, okay, is equal to 100 divided by 100, and that will give us 1 meter. Or you can do it the reverse way. Are you okay? Say, for example, let me give another example over here. Let's say I have 2.5 meters, and I am to convert it to centimeters. How will I go about it? In this case, we are going the reverse way. We are converting from a larger scale, which is meters, and we are going to a smaller scale, which is centimeters. Are you okay? So in this case, we will multiply because we are going to a smaller scale. So if something is big and I'm breaking it into smaller unit, I am supposed to get more. So in this case, it will be 2.5 multiplied by 100, and then this will give me, this multiplied by 10 will give you 25, multiplied by 100 will give you 250 centimeters. Are we okay? So this becomes our answer for this particular example. Are we okay? So these are some basic about unit conversion. So let's quickly look at it. So we are saying 10 millimeters is equal to 1 centimeter. Then we have 10 centimeters is equal to 1 decimeter. Then 10 decimeters is equal to 1 meter. Then from meters to kilometer, we have 1,000 meter is equal to 1,000 meters is equal to 1 kilometer. Okay, so these are the unit conversions for length that you need to know in your head. Once you know it and you know change of subject, you can easily go around it. So for mass, it's also the same thing. For mass, we have 10 milligrams is equal to 1 centigram, and then 10 centigram is equal to 1 decigram, and then 10 decigram is equal to 1 gram, and then 1,000 grams is equal to 1 kilogram. Okay, so it's the same thing. In the first one, we have millimeters. Here we have milligram. The second one is centimeters. In mass, it is what? Centigram. The third one is decimeters over here for length, and then over here is decigram. Then the fourth one is meters over here for mass. It is gram. It's the same thing. Now for time, we already know this already. We have 60 seconds will give us 1 minute, 1 minute, and 60 minutes will give us 1 hour, and then 24 hours gives us 1 day, and 7 of such days give us a week. Okay, and then 4 weeks equals 1 month. Okay, so on and so forth. Okay, so these are some basic unit conversions that we need to have in our mind, and then we can be able to proceed. Okay, so someone is saying I'm late. No, you are not late. So you are not late, you are still on time. You can just go back and watch what we have done so far. So like I said, we've looked at indices, and then we've also looked at a unit conversion, some basic intro. Will be diving more into it. Now let's look at the last one. We did this. Let's look at the last one, which we are calling change of subject. So let's quickly look at change of subject, and then we end today's live stream. So change of subject. So change of subject. Now, change of subject is one of the most common things that happens in physics or in mathematics a lot. What it means is that you are given a particular equation or a particular expression and you are asked to make something the subject. For instance, let's say I have a popular equation we use in physics is initial velocity represented by u is equal to final velocity represented by v minus acceleration multiplied by time. Are we okay? Now, if you look at this, we have our left hand side, and then over here we have our right hand side. Okay, so on our left hand side, we have our initial velocity, which is u over here, and then on the right hand side, we have this expression over here. Now, let's say the question say let's make v the subject. Make v the subject. What that means is that this expression u is equal to v minus at. In this particular expression, the quantity that is standing alone, okay, and it is being equated to the rest, that quantity is what we are calling the subject. So in this particular case, the u over here is the current subject. The u over here is the subject. For example, let's say I write another expression just before we answer the question. Let's say I write another expression. For instance, I write t is equal to v minus u over a. In this particular case, the t becomes our subject. The t becomes our subject, and that is what we are talking about. So whatever is over here and is being equated, that quantity is alone and is being equated to the rest, we can call that the subject. Now, this particular expression can be rewritten as this. Why I'm saying it should be alone is that, for instance, someone can write v minus at is equal to u, or minus at plus v is equal to u. Now, in these two cases, this is case 1 and then case 2. Now, this expression is the same as this expression. In all these expressions, the subject over here is u. Okay, so whether it's on the left hand side or on the right hand side, the subject or the quantity that is alone is what we are calling the unit or the subject of the expression. Are we okay? Now, once we have that understanding, with a little bit of mathematics, indices, and how to move things around, we can easily make something the subject. So let's quickly look at the first answer, the first question that I gave. That is, let's make v the subject in this particular expression. So let me quickly get some space. Okay, so in this case, we have u is equal to v minus at. Over here, we are to make v the subject. It means that v should stand alone. So our key focus here is on this gentleman. We want to make it stand alone. Now, for us to make it stand alone, it means that we have to move the a and t over here to the other side of the equal to sign for v to stand alone. Okay, and in this case, it so happens that the a and the t are multiplying each other, so they are like one unit. We can move them easily. Now, in front of the a and t is negative sign. So when we move it across the equal to sign, when we move these two gentlemen across the equal to sign, the sign here changes to become positive. So I'll have here u. If I move these two gentlemen over here, it becomes positive at is equal to, the v is still here, so I have my v over here. So if I rewrite this, my v is equal to u plus at, and this is my answer for making v the subject in this particular case. So here V is the subject. Now let's say the question says we should make A the subject, the A over here. So we have the expression U is equal to V minus AT. Now for us to make A the subject in this particular case, first of all we need to move the V over here. So we need to move it to this side of the equal to sign. Or what I like to do is that I don't like to work a lot with negatives. So what I'll do is that I'll move, because the A and the T are together, you can move the A and leave the T. You have to move them together. So what I'll do is that I'll take this gentleman and move it to this side, and then I take the U and then I bring it to this place. Now remember, when moving, you need to move and change the signs. Positive becomes negative, negative becomes positive. So in this particular case, when I move the A and T to the other side, because the negative is in front of them, they become positive. So I have AT is equal to here. The V is here. I did not move it, so I'll maintain the V. Now the U, I'll bring it to the place where the AT was. Now over here, there's no sign in front of it, which means it was positive. So if I move it to this side, it becomes negative. So over here, it becomes minus U. So this is what I have. Now remember, in this particular case, we are asked to make A the subject, not AT. Now when quantities are multiplying each other and you want to make one of them the subject, you divide by the other. So in this case, I want to make A the subject. So I divide both sides, divide here by T, I divide here by T. What you do to the left hand side, you do it to the right hand side as well. So what happens is that the negative, the T here will cancel the T here. So I'll be left with only A. And this A now will now be equal to the expression V minus U over T. Now let's look at it the other way. Say this time around we are to make T the subject. Okay. So from here, we will do the exact same thing as we did for making A the subject. We'll move the AT here, then I move the U here. Okay. For it to be easy for me. So I will have AT is equal to, my V is still here. Then I move the U over here, it becomes negative. Now, because this time around I am to make T the subject, the T is attached to A. So I need to get rid of the A. I do that by dividing both sides, the left hand side and the right hand side, by A. So A here, A here. Now, mind you, I am not dividing just the right hand side by only A over V over A, for instance. So if you want to draw the division sign, you extend it across everything, or you do it one after the other. So if it is V, you do the V divided by A minus U divided by A. Or you draw a straight line under all of them and put one A there. It means it is dividing each of them individually. So over here, the A nullifies the A over here. So my T is now equal to V minus U over A. Are we okay? So this is a basic understanding of change of subject and how you can actually go around changing subject. Now there's way more complicated examples than this. This I gave is the most simplest and easy version of change of subject. We have more complicated cases where the parameters are so complicated that making them the subject, if care is not taken, you might get them wrong. But that is why Shakinawa is here to help you. So ladies and gentlemen, thank you so much. This brings us to the end of today's live stream. It's very short. It's not up to exactly 1 hour, but thank you so much for joining. Like I said, we looked at a little bit about indices, unit conversions, and change of subject. Now I would like us to use this opportunity to decide on the time that we want to have the live stream. Okay, so like I said, please comment down in the chat whether you want it to be 8 p.m. to 9 p.m. or 9 p.m. to 10 p.m. Until then, we will be sticking with 8 p.m. to 9 p.m. for our daily live stream. So I'll be posting a poll for you guys to vote if we cannot have it in the chat session. Okay, so thank you guys so much for joining, and I really appreciate you guys. For those of us who joined and we asked questions, thank you so much. So I have one gentleman here, Sally. So Sally, thank you for dropping the heart emoji and then the fire emoji in there. Okay, so Sally, and then we have Julius Nate. So Nate, thank you for joining, and then Mubashir, who asked whether I was a physics teacher. Also, thank you for joining today's live stream. Like I said, I'll be posting the timetable so that we follow daily. So we'll be looking at biology live stream. We'll be looking at chemistry, core mathematics, physics, and elective mathematics as well. All right. So someone said we should stick to the 8 p.m. 8 p.m. to 9 p.m. So we can stick with that as well. Are we okay? Now, like I said, this platform, my science tutorial, we have a lot of lessons on, or a lot of YouTube videos created for students already on the platform. So we have a lot of videos on the platform already. So we have a lot on physics, we have a lot on biology, we have a lot on mathematics, both core and elective. We have a lot on chemistry, both organic and inorganic, or even physical. We have a lot of video lessons, individual video lessons on the platform. So if you are here and that is something you want to look at, please make sure to go to our page and then look for each video that you want, or just go to the page, use the search button, search any topic you want, it will pop up. Now with time, we'll be having paid versions. Just for some small token, you have exclusive access to most of our detailed uh, past questions and stuff, which for now is not there. For now, we just want to get as much audience as we can because we love you guys and want to make these things free for now. But you can help support the channel by liking the video, sharing the video with your friends and colleagues that may find this video helpful. Like I said, we'll be doing lessons. It's all about lessons. We'll have Q&A sessions today. The turn up is a little bit better, but with time we'll have more people. We'll be doing live Q&A sessions where we look at past questions, objective and subjectives, right? So you have the slide showing the question. You have some few seconds to give the right answer, and then we proceed to the next question. For those of you who will be getting the right answer, we will be having some giveaways for you guys along the line. So I'll be taking note of each and every guy who participates in our lessons, like our video, share and comment. I'll be taking note of you guys as well. So thank you so much for joining. I really enjoyed the session with you guys. So thank you so much. Like I said, I will be sharing the timetable by tomorrow so that we know what we are having each and every day. And until you guys comment in the comment section the topic you want us to treat, we will be going with the timetable that I have. But if we have anyone who has a particular problem with a particular topic and you just mention it in the comment section, once you have more likes on that particular topic, we'll look at it. So in as much as I will be teaching and will be looking at the past questions, I'm also attending to your needs. So if I realize that most of you guys have difficulty in a particular area more than the other, we'll focus more there than the other. So thank you so much. Guys, please, like I said, this is the end. So let's drop some love emoji, some fire emoji in the comment section. Let's make it hot. Let's make it hot. And if you've not liked the video yet, please make sure to like the video because it will help YouTube algorithm push our live stream to more and more people later in the future. So please like the video, share, comment, and then thank you so much for watching. All right. Okay, let's keep liking, let's keep sharing. Then thank you so much for joining the first ever live stream for Shocking Hour. Okay, Shocking Hour is going to be amazing, it's going to be entertaining. So thank you so much. If you are here and you've still not subscribed to my science tutorial, this is the perfect opportunity for you to do that. And also you can use the comment section. If you look at the description of this live stream, if you go to the description, we have our social media handles over there. You can follow us on Twitter or X at x.com/my science Twitter, or you can go to TikTok and just go and search my science tutorials. You'll see us on TikTok, and then you also see us on YouTube right here on my science tutorial. So please comment, like, and share with your friends and colleagues. So thank you once again, and bye bye.